This is Shivakumar. Today we are going to discuss about the properties of solids. In previous classes, that means it's about the 7th and 8th classes, there we have studied about the properties of matter. So, properties of matter we have studied in lower classes, right? So, matter consists in 3 states. So, matter consists in 3 states. What are they? So, matter consists in 3 states, right? So, matter consists in 3 states. So the first one is solids. Next liquids and gaseous. Right? So in solids we are having particular volume, density, shape, size, everything is considered. Everything will be there in the solids. So volume, density, shape, size. So all these are there for the solids. Whereas compared to the liquids, we are having the volume, density, and it does not have particular shape and size. But whereas the solids is having the particular shape and size, right? Okay. So volume, density is having by the liquids, and it does not have particular shape and size. It attains shape of container, shape and size of container. Container means what? That is the object which we are taking inside for the liquid. Let us take the water bottle. So water bottle, in that water is a liquid, whereas compared to the bottle is a solid. Bottle is a solid, right? So this object is also a solid. Water is a liquid. So here what happens, if you take, let us take this ball, let us take this bottle. So then what happens in that this bottle is water, this is a solid, and the inside of this is liquid, right? So here what happens, the shape of this liquid is attained by this container. So here the container is the bottle. Are you getting? The container is the bottle here. Okay, and next coming to the gaseous. So it does not have particular shape, particular volume, particular size, and particular density. Okay, it attains the shape of container. Let us take this. Okay, so in that we are having this part is having the liquid, and this part we are having the gases. Right? So here what happens? There is no particular shape, size for the gaseous. No volume, no particular shape and size for the gaseous. No size, shape for particular gaseous, right? Okay. So in this first we are going to discuss about the solids, right? So solid. So let us take the solid, right? So solids. In solids we are having particular volume, density, shape, size, everything is fixed, right? So is it a solid or liquid? Yes, it is a solid. So I would like to apply some force on this object. Then what happens? So let us take a pen. So I don't have a pen right now. So let us take this object only. Let us take this object, right? Okay. So this object is the solid. Okay. So this object, I am applying some force towards this side. Okay. Then what happened here? This object is changed its state, right? Change its shape. Okay, so then what happens? Why it changed its shape? Why it changed its shape? By applying the force? Yes, of course. By applying the force, we got this. We changed the shape of this object, right? So after removal of the force, then it attains to its original configuration or not? Yes, it attained its original configuration. First it was there like this, okay? Then I am giving some force towards this side, okay? Then what happened? This object changed its shape, right? See this? The shape of this object is changed. So after removing this, then what happened? This object attains its original configuration. Why? That is what we are going to learn in this chapter. Okay? So when we are applying some force on this, then what happened? It changed its shape. So coming to that force is called, whenever we apply some force on any object, if that object changes its configuration, then we can say that is deforming force. So let us write the deforming force. So deforming force, deforming force. So what is deforming force? Deforming force is that force that changes its configuration of an object when we applied a force. That force is called deforming force. Okay, so the force which is going to change the shape of an object, then that is called the deforming force. Okay, and here you see, whenever we are applying some force on this object, after removal of the force, then it attains its original configuration or not? Yes, it attains its original configuration. So here what happened? Why it occurred? Why it came to its original configuration? Why? Because due to the intermolecular force, it attains to its original configuration. See, whenever we are applying, say, let us take here. So a force is there here. Okay. So an object is there here. Let us take A, and another object is there here. So B. So then what happened? These two are getting collide each other. Then what happened? Then the force of this object A comes and implement on this B. Then what happens? This B is going to change its shape, right? So after some time, the intermolecular attraction, the intermolecular repulsion, okay, due to the intermolecular repulsion, then it will comes to its original configuration, right? So it is looking like the same thing. So after removal of the deformation force, it regains its original configuration. That is called the elasticity. Okay, next one is elasticity. Elasticity. What is elasticity? When the deforming force is removed, when the deforming force is removed from an object, then it attains to its original configuration. Then that object is said to be elasticity. Okay, right. Next one is plasticity or plastic. Plasticity. So what is plasticity? Plasticity is what? So here what happened? Let us take this object, or else I would like to take. No. Okay, right. So here we are having a chocolate, right? So here I am applying some force. So I am just applying now. Okay, I am applying some force towards this. Then what happened? It does not change. It's a configuration. It changes, but it regains to its original configuration. So after I remove this, I change its configuration, right? So this chocolate is for me only. Okay. So I just changed the configuration of this object. So then what happened here? Here what happened? The shape is changed. Is it regains to its original configuration? No, it will not get into the original configuration after removal of the deformation force. Okay, so that is called plasticity. So the definition of the plasticity is that after removal of deformation force on an object, it does not get into original configuration. Then we can say that is the plasticity. Okay, so we are having perfectly elastic and perfectly plasticity. So what is perfectly? Here, let us take the perfectly elastic. Perfectly elastic. What is perfectly elastic? So we know that the definition of the elasticity, when an object is getting deformed, after removal of the deformation force, it regains to its original configuration. But here we are using the perfectly, right? What is that perfectly indicates? After removal of the deformation force, immediately it regains to its original configuration. Is called perfectly elastic. Here what I am using, after removal of the deformation force. After removal of the deformation force, immediately it regains to its original configuration. Then we can say that is perfectly elastic. Next, coming to the plasticity. Perfectly plastic. Perfectly plasticity means what? Perfectly plasticity. Okay, perfectly plasticity. What is that? So, whenever we apply some force on an object, right? So, it does not get into original configuration at all. It will not get into the original configuration. Let us take this object, right? So, I just tear this one, right? So, then what happened? It changed its configuration. So, will it be come to the original configuration after so many times? So, after some time, will it come? No, it will not come. So for that reason we can say this is perfectly plastic. Perfectly plastic. The object which does not get at all into the original configuration, then we can say that is perfectly plastic. Perfectly plastic. Okay. So now we'll write. Now we'll see. I will write again. Attain. Shape, size, I write. Okay. Now we'll see stress. Stress. What is stress? So we people think that stress means we always think that the stress means that whenever we do some work, then we are going to get the stress, right? So is that stress and this physics stress are same? It may be same, right? Okay, now we'll see the stress. So, stress is that when we apply a deformation force. When we apply a deformation force. We are talking about the deformation force, right? Right? So, when we apply a deformation force on an object, then what happens? The change of the size or shape is going to be taken place in that particular object. So there what happens? Let us take a rod. Okay. So here I just took a rod having the length L. Okay. It is having the length L. Okay. So I would like to give some force. Towards this direction. Okay, then what happens? It changes its configuration, right? Changes its configuration. Then what happens? It comes to here. This is called the change in the length. So whenever we are having some length of the rod having L, if we give some deformation force, here I am using the deformation force. If we give some deformation force towards this direction, then the length of this object is going to be changed, right? So after removal of the deformation force, then what happens? It regains to its original configuration or not? It regains to its original configuration. Not here. It will not move to here. It will be like this. So like this. So this is length L, and here what happens? This L is correct. Okay. So here what happens? This is the original length of the rod. Firstly, but here what happened? Here the change in the length is going to take place. The change in the length is going to take place. That is delta L. This delta L are different. Or we can take a change in the length. We can write here length change. Change in length, and this is also change in the length. I'll write again. So this is change in length. Change in length when deformation force is applied. When deformation force is applied. When deformation force is applied, then the object is going to be changed. Right? Change its length. So here what happening, if the length is changing, here, then will the force changes or not? Whenever we are applying, right? So here we are applying some force. Okay. So if it is increasing in length, then will our force is changing or not? Yes, definitely the force is also changing. How? Let us take here we are having particular area. Here also we are having particular area, right? So whenever we are giving some force to particular area, then the object here I am taking rod, right? So the rod is going to change its length, right? If the length is changing, then automatically the area is also going to be changed, right? So then if the area changes, then the force is also going to be changed, right? So when the deforming force is applied on an object, then the particular area, then the area is going to decrease or increase. Okay, I would like to take here I am taking as decreasing area. Okay, if the decreasing area and the force and the length is also increasing, the area is getting decreased and the force is somewhat varying, that means changing. Okay, so coming to the stress. Stress is nothing but a deforming force is applied to a particular area. Deforming force is represented with sigma. Deforming force is applied to a particular area. So sigma is stress. So deformation force per unit area. Okay, so deformation force per unit area. So we can also take this is the internal restoring force. This is also the same thing, right? Internal restoring force per unit area. So here what happens? Stress is that the restoring force per unit area or deformation force per unit area. Here what happens? Here when we apply deformation force, the same force we are going to get to the restoring force. So here what happens? Restoring force is equals to the deformation force, right? So for that reason we can write like this. So sigma is the stress. So the ratio of deformation force to the ratio of the deformation force to area. Okay, we can also write the definition of the stress is that the ratio of deformation force to the area, or we can also write the restoring force per unit area. So do we have SI units? Do we have units of the stress? Yes, we are having the units for stress. What are they? So here you see sigma, right? So sigma, here I would like to write the sigma, right? Sigma is that stress. So restoring force, here we are having the force. So that means force per unit area. That means we have to go to the fluids, right? So force per unit area is pressure. So here this may be equals to the pressure. Right? So the unit of this will be equals to, here we are having the force, right? Force means Newton, and by area unit is meter square. So meter square. So the unit of the stress is equals to Newton per meter square. Okay, we can also write it in the form of kg meter per second square per meter square, right? So this meter and this meter will get cancelled, so the remaining will be kg meter per second square. I would like to write it again, kg meter per second square, right? So Newton per meter square, kg meter per second square. Okay, and dimensional formula. What is the dimensional formula of this stress? So here we are having kg, and here we are having meter, here we are having seconds. So here we would like to take m, l, t, right? So M, the kg is having 1. So mass should be taken as 1 meter. Meter is in the denominator. So for that reason we need to take -1. And time is in the denominator and it is in the square. So we need to take -2. So here this the dimensional formula of stress is equals to M L inverse T inverse square. Okay, so n to the power 1, L to the power -1, T to the power -2. Okay, so here what happening? The stress is that when we apply a deforming force, then the change in the length is going to take place per particular unit area. Is called the stress. Okay, so when we apply a deformation force to a particular area, then the object is going to be change its state of size, right? So then what happens here? The object is going to be change in its length when we apply the deformation force. Okay, so we are having three types of stresses. I would like to write it here. I want to erase this. Okay. So here stress is there, right? So stress means what? Stress is that the ratio of deformation force to the unit area, right? So stress is having three types. What are they? So stress is having three types. So the first one is longitudinal stress. So what is this longitudinal stress? So longitudinal stress is that stress when the deformation force is perpendicular to the unit area. Not unit area, it's about unit area. It's about area, that's it. Okay. So the longitudinal stress is that the deformation force is applied perpendicular to the area. Then that is called longitudinal stress. Okay. So here the longitudinal stress, it is also called as normal stress. So what is normal? Normal means here 90 degrees perpendicular, right? So here force and area to be perpendicular to each other. Then we can say that is longitudinal stress. What is that? That is the stress. Longitudinal stress. Force is to be perpendicular to the unit area. Okay. Force is perpendicular to the area. Okay. So this longitudinal stress is also having two types. So what are they? First one is tensile stress and compressible stress. Okay, so tensile stress. So we'll discuss about the tensile stress and compressible stress. So let us take a rod of length L. So here we are having a rod of length L. Okay, so if we give some force, that is deformation force, I would like to give here. So here we are having area, right? So the area and the force to be perpendicular to each other. Here I am not taking like this. I am taking like this object. Okay, so I am taking this. Okay, then what happened here? Then the object is going to change its length, change in the length. So then what happens? This object changes its length, right? So firstly it was there up to the length L. Now after giving the deformation force, it took the length dl. So additionally it is increased. Additionally means what? The length is also taken from this rod only, right? So here what happens? When the deformation force is applied perpendicular to the area, then the change in the length is going to be taken place. Then that is called tensile stress. Okay, so here what happens? The change in the length is going to be taken in the direction of the force. In the direction of force. And coming to the compressibility. Coming to the compressibility. So what is that? Let us take the same rod. Okay, so I am giving the force perpendicular to this area. Then what happened? This object, this length, here I am taking the length of the rod is L. Okay, so after giving some deformation force, then this object is getting compressed. Right? So then what happens? It was there like this first. Right. So here what happens? At first it was there L, right? So then what happens? This become L minus delta L, where this is the delta L. Delta L is change in the length. So here what happened? When the force is applied perpendicular to the area, then the change, the decreasing in the length of the rod, then we can say that is compressible stress. Okay, so here the first one is longitudinal stress. The definition, it is also called as normal stress. The definition of the longitudinal stress is when the deformation force is applied perpendicular to the area is called the longitudinal stress. In that we are having two types. The first one is tensile stress and next one is compressible stress. The first one is the tensile. Tensile means when we apply the force perpendicular to the area, then the increase in the length is going to be taken place. So for that reason we can say that is the tensile stress. And next one is compressible stress. Compressible stress means what? When we apply some force and if that rod is getting decreased in the size, then we can tell that is the compressible stress. Here also we are going to use the force to be perpendicular to the area. The force should be perpendicular to the area of this rod. Then we can say that is compressible stress. Shearing stress. Second one is shearing stress. Shearing stress. Okay, right. So shearing stress is what? So let us say a deformation force is acting tangentially to an object without changing its volume. So let us take a cube. Okay. So here we are taking a cube. Okay. Right. So here what happened? Here we have just taken a cube. Okay, having the length L. Okay. So I would like to apply a force, a deformation force, tangentially to this object. Then the object will going to change its shape, but not volume. The volume is not going to be changed in the shearing stress. Okay. So here the object is going to change in the, like this. Right. So here you see, here when we apply some deformation force towards this direction. So here what happens? When we apply a deformation force towards tangentially to this object, then this object is moved. This object is moved here from here to here, right? So then this is called shearing. This is called shearing stress. So here what happens? Here the formula of this shearing stress is also the force per unit area. This is shearing stress, right? Shearing stress. So sigma S is equals to F by A. A is area. So here what happens? Here in shearing stress, here the volume is not going to be changed. So here what happens? The volume is constant. Volume is equals to constant. Volume is not changing here. Here the definition of the shearing stress, right? When a deforming force is applied is applied tangentially to an object, okay, so to an object, if the object changes its shape without changing its volume. Okay, so shearing stress is that when a deformation force is applied tangentially to an object, if the object changes its shape without changing its volume, then we can say that is the shearing stress. Okay, so next we'll see the third one, that is volumetric stress. Okay, so here we are having volumetric. That means volume is going to involve in this, right? So let us take a geometrical shape. Let us take a sphere or any object. Okay, so a body is getting deformation force in all the directions. Okay, then the original configuration of this object is going to be changed. Then the change in the configuration is going to be changed. Change in the configuration of this object is going to be changed. So then the volume of this object is going to be changed. So then what happens? If the force is applied in all the directions to the object, then the object is said to be the volumetric stress. Okay, so right. The force applied in all the directions of an object, then the change in the volume is going to occur. Then that is called volumetric stress. So the formula for this also will be equals to S volume, right? So Fv is equals to the force applied per unit area only. So here also, let us take, if we are taking at this point, the force is perpendicular to this particular area. Okay, so the force is perpendicular to this area here also. Okay, so here the volumetric strain, when a force is applied perpendicular to particular area in all the directions, then the change in the configuration, the change in the volume is going to be taken place. Then we can call that is the volumetric stress. Okay, so now we'll move to strain. Now we'll see strain. Okay, strain. So what do you mean by strain? After doing so much of work, we say I got strain, so I don't want to come. So what is that strain and what is this strain? I don't know about that. Okay, but I know about this. Strain. What is strain? Strain is that when we apply a deforming force on an object, if that object changes its configuration, then the strain is said to be the ratio of the change in configuration to the original configuration. So here what happens? Strain. The strain is the ratio of change in the configuration. Change in configuration. Change in configuration to the original configuration. Original configuration. Right. So it is represented by E. Okay. So strain is that when we apply, right. Strain is that when we apply a deformation force to an object, if that object changes its configuration, then strain is said to be the ratio of change in configuration, change in configuration to the original configuration. Okay, so here do we have the units of strain? Here we are having the change in configuration and original configuration. Let us take here, let us take when we apply a deformation force on a rod, right? So then what happened? This object is changed its length delta L, right? Since original configuration is L, right? So here what happens? Let us take the delta L, right? So delta L by L, delta L by L. So L is the length, L is the length. So meter by meter. So meter by meter is cancelled. So the strain does not have the units. Strain does not have units. Okay, so we are having three types of strains. We are having three types of strains. What are they? First one, longitudinal strain. Longitudinal strain. Right. So in stress we have discussed when the force is applied perpendicular to the unit area, then there is a change in the configuration. Right? So let us take that one. So this one only, right? So when we apply some force towards this, then the change in the configuration delta L, right, in this, right? So then the longitudinal stress is that the change in the configuration. Here we are taking the length, right? Changing the length by original configuration, that is original length. So here what happens? Longitudinal strain is that change in the length by change in the length by change in the sorry, change in the length by change, not change, change in the length by original length. Okay, so this is the formula of longitudinal strain. Longitudinal strain is EL is equals to delta L by L. Okay, so delta L is change in the configuration. That is change in the length delta L, and L is original length of the object. Okay, now we'll see shearing strain. Okay, second one is shearing strain. Shearing strain. What is shearing strain? So in first we have discussed about the shearing stress, right? When we apply a force, a deformation force to the tangentially to an object, then the change in the configuration is going to be taken place without changing its volume, right? So let us take an object here. So I would like to take a cylinder here. Okay, so I just apply some force tangentially to this. Then what happens? Here the base is not going to move. Okay. So here what happened? This object is moved up to here, right? So then what happened here? The change in the configuration is taken place without changing its volume, right? So originally it was there like this, right? So this indicates the shearing strain. So the change in the configuration to the original configuration. Right, so I would like to take from here to here, I would like to take X. From here to here, I would like to take L. Okay, so the theta means here shearing strain. So E theta will be equals to X by L. Okay, X by L. That is the change in configuration by original configuration. Right, change in configuration. Here I just do the X here. Okay, X. Changing configuration is X by L. Changing configuration by original configuration. Right? Now coming to the volumetric strain. Volumetric strain. Right. So when we apply a force, deformation force, perpendicularly to the object in all the directions. Then this object is going to be changed its configuration. That is the change in its volume, right? So that is that change in the volume. So here, if we apply some force, then this object is going to be like this, right? So it's going to be change its configuration here. Here the configuration is volume. So here what happens? Here the volume is getting changed, but here the volume is not changing, right? Are you getting my point or not? when the volume is changing here, but not here. Here the configuration is changing, but now volume is not changing. But here what happening? The configuration is changing, and as well as the volume is also getting changed here. Okay, so then what happens? This. So originally it was there like this, right? So then the change in the configuration, delta V by V. So the volumetric strain is that the change in volume to the change in, the volumetric strain is that the change in volume to the original volume of an object. Okay, so these three are the three types of the strains. So we have discussed about the stress strain, right? Okay, I would like to revise again here. Okay, so with deformation force, we have discussed about the deformation force, restoring force, elasticity, plasticity, right? And coming to the stress strain. So stress is having three types. Stress is having three types. First one is longitudinal stress, longitudinal stress, and next one is having the what do you call shearing stress, and next one is volumetric stress. So it is also stress, right? Stress. In longitudinal stress, we are having two types of stress. One is tensile, another one is compressible. So the first one is tensile, and another one is compressible stress. So coming to the strain is also having the three types. Strain, it is also having three types. First one is longitudinal strain, and another one is shearing strain, and third one is volumetric strain. So by this we are going to discuss about the modulus of the elasticity we are going to discuss. Okay, so by the stress and strain only we are going to discuss about the elasticity of an object.